Good morning, good afternoon, good evening, everyone. Thanks for joining this weekly webinar series. As you all know, I am Krishna Reddy from University of Illinois, Chicago. So we have a lot of different topics, every week. So you're not going to get bored. So this webinar series is sponsored by ASCE, Geoenvironmental Engineering Committee, and also ISMGE, Environmental Geotechnics Committee. So today we have a very interesting webinar. And then you see that one, next week also we have a very, interesting webinar. So hopefully you can join every week. So previously recorded webinars are here on this YouTube channel. You can go back and review them. So if you are new to geoenvironmental engineering or sustainability, these are the good sources to start with. So we organized this EGR WSC conference. So this year it's going to be in Surat. I hope to see many of you. There is
Yeah,
an
sure.
overwhelming response to submission of the papers, and a lot of people wants to attend the conference without papers. So we have extended abstract opportunity. So you can submit an extended abstract and then present your paper at the conference. So these links are there. You can find it. I will post this presentation again in the chat box. Those who didn't get it, they can get it again. So as of yesterday, we had 572 registrants, and this morning I keep getting more registrations. But please mute your mic and switch off your video. So at the end of the presentation, you can quickly show your video so that we can have a group screenshot, and then you can type your questions in the chat box or raise your hand and we will unmute you and you can ask the question directly. So our presenter will answer as many questions as possible. So if you are interested in getting certificate of participation or one professional development hours, you need to follow these instructions carefully, otherwise you're not going to get it. You must attend the entire webinar, and then you should also fill out a Google form. That link will be posted in the chat box towards the end of the presentation, and then you must fill out that form before the webinar ends. So if you follow all these things, you will automatically get the certificate of participation. So today's webinar topic is very, very interesting. Landslides and erosion control. As you know, there's a huge problem all over the world. And using bioengineering techniques is really, more sustainable and resilient. So it's a really nice topic today. So we have very experienced researcher in this field, Dr. Chandan Ghosh. He has distinguished academic and professional career in this particular topic of disaster management and civil engineering. So he served as a professor and head at the National Institute of Disaster Management, where he has been instrumental in developing disaster resilient infrastructure and management. He just recently retired, but he's still very active. His contributions have been recognized with several prestigious awards, including the Leonard Prize for the Best Doctoral Thesis in 1993 and the Lifetime Achievement Award in 2019 by the Indian Geotechnical Society Delhi chapter. And Dr. Ghosh's expertise extends to earthquake geotechnology, seismic microgeneration, and bioengineering applications, making him a key figure in disaster risk management in India. So with that brief introduction, I want to thank Dr. Chandan Ghosh for taking the time to give this webinar. And I want to thank you all for joining. And with that, let's learn from this interesting webinar. So I will stop sharing. I request Dr. Ghosh to share the screen and start his presentation. Thanks, everyone.
Thank you, Dr. Reddy. And it is really a wonderful opportunity you have given and your sustained effort for sustainability. Even after from COVID onward to till date, and more activities are coming up. So for me, it is a privilege to be in the world of bioengineering, although it is not more than a decade ago. But with the constraints and difficulties in introducing bioengineering, especially with vetiver grass into the mainstream research as well as application. In fact, I have visited many of the sites. Even yesterday also I came from one of the sites where vetiver grass is being used in highways, slope stability. So through this session, I'll go with most of the case studies, and I should not say it is a performance study, but performance will take more time and spirit in our research and academia as well as in the field practices, which is lacking. But what I'm going to highlight with some of the things I'm directly involved and some of the things that indirectly that the world of slope stability and erosion control can recognize whatever grass as, I should not say, rather with emphasis that you'll come to know that it is not one of the, it is solving many of the problems so easily. And so easily is that I'm going to highlight and many complex things, how it is going to take care. So I'll go by only some of the photographic details as much as possible with the time limit given to me. So what I'm going to see that just day before yesterday, today is 27, I have been to one of the green expressway, where whatever grass is being applied. Here you see this, they are using geocell here. And geocell, what we have seen, which were developed maybe 15 years back, and how much simplified it has become, and how much easy that it has become on a slope, where this is a concrete road, and this is two vertical, one vertical, two horizontal, which is not at all a slope stability problem, but still, this kind of green expressway, especially in the state of Bihar, is the first such highway in an expressway grade that it is under construction for the last 1.5 year, where site visit has we have taken place. In fact, National Highway Authority of India recommended that to see that whether these kind of applications are going in a right manners or not. So I was there. And in fact, on this site, you can see that some of the application they have made 7 months before and how grass has come up. So these are ongoing, just they are going to put up the grass here itself. It is about 42 kilometers. And in fact, I have taken some of the video also on that. I think if time permits later on that I'll show, especially that what we have done on the field by pulling out physically and check that whether it is the right variety of vetiver grass or not. And then we have interacted with various officials over there, including the applicator and the sourcing of the vetiver grass from the nearby, and how much is their cost and what is the operational cost and what is the maintenance cost. There are so many things to share. So I'll go in another way. So this Ganga Expressway, another one I visited on 27th January. It is made by our largest construction company, L&T. It is again under NHAI. And see that green colored coir mat they have used, and in that they have used a vetiver grass. This is hardly 1 month old, but they are growing. But one of that which was applied more than 1 year before, on another part of the same road, they have come in this manner. And here again, I have taken a full video of these things, which maybe I'll share later on, if time permits. Then, and also what they are providing is that this kind of should drain every 20 meter with such kind of, water barrier, silt barrier channel and other things. So these are all put into the standard practice. But later on, what we are going to suggest over that, even such kind of shoot channel is also not required because it is also very costly. But when it is at 1:2, means one vertical, two horizontal slope, they are already gentle slope. So in that case, we are going to suggest them our recommendation that that shoot drain also is not required in these cases. And even such a coir mat is also not required. Here it is a green colored with some coir mat is there. Hardly per square meter 4 or 5 vetiver grass have been planted. So I'll come with some details about the planting of vetiver grass. And our persistence in slope engineering domain even though the slides that I have shown, these are all prepared slope in a roadside embankment, which are varying from say 2 meter to 5 meter. Even in some cases, a 10 meter, 12 meter slope also is there while making such kind of expressways. So there we are going to recommend very soon by another 15 to 20 days what will be the type of vetiver grass they are going to use and enter recommendation which will be included in their guideline. But how we are persistent enough in taking whatever grass into such kind of road projects, just to say that we make DPR, then BOQ, then tender, then budget declared, then over that budget, L1 is selected, and L1 is also less than the budget that they have quoted. This I have come to know after coming out from an IDM while working with various agencies in the last two years onward. And underquote 30%, 40% entire budget, and then no chances for H1 means higher one who is specific enough. Then things are given in EPC mode, BOT mode, HAM mode, hybrid mode of constructions where government and the company itself, they share certain percentage and over 15 years of, collecting tolls and everything. Then when construction start, then they find out when it is in EPC mode or BOT mode or HM mode, the contractor or the agency, they find out is there any easy, cheaper solutions. Then the main client here, say NHAI, they get aware with. So people like us, we visit there, we convince them on behalf of APC contractor or on behalf of the NHAI. Then we say that which is the alternative solution, and then client gets aware with, oh, okay, then give us suggest. Then it takes few months of time, then they adopt it. Then make alternative solution, and then they call field experts like us. Then we make some kind of reports, then arguments takes place. And from the argument side, authority engineers are there. Nowadays, they use AI to make the critical comments. So we receive a lot of comments from the authority engineers that why this is so, what is the formula, how slip circle is rule is violated, how it is going to save, what is the factor of safety, what is the root area ratio. So there are many such key points are there which they put many questions from the basics of soil mechanics or slope engineering that we know of, where more than 20 methods are there in satisfying that factor of safety, maybe more than 1.2 or 1.5, which are very much well known in our slope engineering or geotechnical engineering domain. Then what is happening that getting the work done, I have shown you a few of the things which we are going to make comments to the appropriate agency that whom we are about to submit. And then especially unskilled manpower we saw, and it is becoming a choice by many because it solves problem to some extent more easily and cheaper manner, and if identified by field experts. And in fact, we have very few field experts in the country right now. And if I give you a little bit of estimate that I have come to know, about 4 such slips are placed per meter square to 20. Someone puts even 2 or 3 in bunch, and so it may be 20 or 30 such slips. Each slip costs hardly 1/7 of Indian rupee while you purchase in bulk. Then costing, I would say per meter square, it doesn't cost even 10 rupee or 10% of 10% of a dollar, you can say, in the current value. And finishing the same with rates as high as 100 times for 1 meter square by some conventional solutions available, even as per which are, of course, taken up in the DPR or BOQ in the initially. So even Indian Road Congress or BOQ use stone pitching is recommended in most of it is already Indian Road Congress and guideline they have made the stone pitching, but stone pitching are not preferred these days because they are not sustainable. Because the context of today's seminar is they are not sustainable. They are 10 times more costly. They are 100 times more costly, 1,000 times more costly, and not sustainable. So that is the context that I would like to say. When we talk about the slope engineering, how we create landslides, which we call landslide doesn't happen naturally. We create landslides while making roads in this manner, which is very well known. And we also make roads in our country or many other parts that they come down even before construction finishes. And they leave, we just leave it because by making a retaining wall, a soil nailing is not feasible in many cases because they are too costly, sometimes costlier than the road making construction cost itself. So they are not affordable. But what happens? Many of the places we do such kind of conventional construction, even though the geotechnical engineering has enriched in making such kind of construction in this manner, where the wall doesn't take much of the pressure which is taken by the geosynthetics reinforcement. But we often go for this kind of construction which doesn't solve the purpose. It rather makes the slope more heavier. So, and in that case, what is happening is that bioengineering versus the slope engineering that I'm talking about in this way, which we are adopting this manner, somewhere we are adopting this manner, but each one of these are very costly. Sometimes they are not affordable. And sometimes they are not feasible also in many of the road slopes that I have shown over here. So, because right of way is defined already. So there are many constraints. So, what is required while entering into the bioengineering is that learning that we had in our discipline, and we have to unlearn many of the things which I'll show by case example, and we have to relearn from the nature. That is the motto of today's interaction. So in order to that, geotechnics that we think we know of so far about landslides, it is tremendous progress that we have made. Unpredictability domain of landslides, occurrences, and limitations for early warning, which we know. Modeling and interpretations, not many vying with the nature, actual nature, that what is happening. Nature-based slope mitigation, our perceptions falling apart, and we are yet to go miles together. And so how bioengineering for landslide mitigation case examples which I'm going to take part. This is some of the slopes that which was done in Assam itself, in Guwahati. I visited there in 2012 when I came aware of the bioengineering with vetiver grass here. And with a small breast wall and slope angle, you can see more than 60 degrees, 70 degree, which we cannot define geotechnically how slope of this, whereas for the highway slope, we are making mandatory that it has to be one vertical, two horizontal. But wherever road has been made in this manner, some of the cuttings that you have seen or still going on in many places, it is just by putting a breast wall of this one and putting grass, or I'm not saying it is still engineering part will come how it works later on, but these are self-sustainable at least for 10, 15, 20 years. But we will see that performance of these things, it is obvious that they are performing well, but how long? 10 years, 20 years, 30 years? That is yet to be studied. Although there are some case studies are there, even after 20 years, they are sustaining. And this is the grass that which grows. In fact, when I got the first grass in 2013, then I have grown them in my campus, an IDM campus in Delhi. So context is some of the example that I'm showing here, which probably are missing in the class. Of course, class is to be held in the field itself, and which are taking place when we visit this kind of sites. And what are the geotechnical and what are the geotechnical versus nature-based solution, which we are talking about a lot of guideline publications, conferences, seminars are being held. But here we will confine to geotechnical part and how it is being taken care of by bioengineering by vetiver grass. And along with that, erosion control measures that which have been traditional versus modern, and how modern one is failing and how bioengineering part is taking the main role. And how to live in the hill area, that is also I'm going to tell about that. So what we know about techniques of slope is that route is going in this way, and we are familiar with for so many years that we do the test, and we find out that what is the C and phi. And we all know that what is the soil and their parameters, and we all determine all these things, routine test we do. And from that, in fact, we do also this kind of inhomogeneous, non-homogeneous test also in the sample, although it is not qualified to be tested with such kind of grassroots inside. But this is where is the limitation of geotechnics, that we put everything in the triaxial sample and then try to see that what is the contribution of the root in this way. But this is not the way the root functions, because it is a living nail. So still we have to go a long way to understand the slope mechanics with respect to the root mechanics, or bionail rather, which grows every day by 1 inch or 2 inch inside the soil. So how biomechanics of roots have to be brought into the constitutive modeling, that is still experiment as well as investigation modeling part which is going on. So what is happening is that in a large triaxial sample also, when we do such kind of test and justifiably, just I think it is in the parlance of geotechnique, we cannot justify the result the way that it is coming over here, because this is not happening in the field. But this is at best that we can do such kind of test in our laboratory, and also some of the shear tests that we do in our laboratory. But what is that maximum angle that we can do? It is 45 plus 5/2. So, but I'll show you that even slope with grass more than 70-degree, even 80-degree, even 90-degree slopes are getting stabilized by uh, this grass, and which I'll show in detail. But on the other hand, this is a publication, very famous publication, that how we treat the slope from failing even by inserting perforated pipeline. So, but this much is not happening in majority of the in our hill areas. And even if we could do this much, we could have saved many of the slope from failing. So, but what is happening really, even in the new road, this happened in the last year, May 21, and that it has failed. So, who is to blame in such manner? It is engineers, contractors, or the entire system, or the soil that we fail to understand altogether. I think because it is all BOQ and all those things that I have mentioned, L1 and everything have been followed, but it has failed here in this way, and it becomes a serious debate. This happened in Kerala, you can see in the report. Or when such kind of failure occurs, engineers are responsible, is it? Of course, we can say expected, unanticipated things might have happened over here, or we can raise several such questions. Damage and loss assessment and other thing, cost and disturbance cost to that, we are answerable these days. And in fact, what again from the nature that we have been able to gather, where explanation doesn't give any such kind of reliable solution, is that for more than 4 decades, this road is functioning in our country or in many other parts of the world. And what is happening is that we cannot fit any mechanics that we know in this manner. I think we have to unlearn in this way, that how nature is giving us a shelter to make a road in this way. And we have to relearn. And also we are creating such kind, it is in Hindi, it is say that while it is written there, Ishwar ko yaad kare, those who are from India, you know that what is the meaning of that. So what we must reduce the gap between what we do not know about the mechanics here and what we put on our God or something, that there is a lot of gaps are there, and these roads are functioning to our for our purpose. And there are many of these kind of preventive measures are there in the natural way. Now I'm going slowly into the natural way, but these are not feasible because lots of work is manual labor is involved. And these are also jute geotextiles are also used. The bamboo as a check dam also used, but these are not long term. These are again not sustainable in that way. Lots of care is required. And so, what is bioengineering then? It is, of course, it is written over here. The concepts and method of biology, of course, we understand very little of that being engineer. And secondarily, in fact, it is a principle of physics, chemistry, mathematics, and computer science all together. The engineering part or bioengineering part we look into. And to solve real world problems, that some of which I have shown you, to life sciences, or the application thereof using engineers' own analytical. This is where that we have to relearn from the case studies that we are going to see now. And synthetic methodologies also, its traditional sensitivity to the cost and practicality of the solutions to be arrived at. So let me go little case example. This is the most well-known figure over here, both above the stem and below that how it is functioning. It is a most well-known photograph that I think circulated among in the internet or everywhere, and we know. And what is a beautiful application of the natural way that that it does? What it does, all these mechanics that leachate and everything comes over there. Of course, I am not concentrating over there. You can see some details in the many of the literature that available over in the internet. And vetiver grass, in fact, in our country, different state they call it in a different manner. And then how much it can grow. And in fact, this is from Mexico, how much it can grow, 2 meter, 3 meter, even maximum recorded, it is about 8 meter, 8 meter inside the soil. And where from this word, whatever came up, this is over here from the state of Tamil Nadu. And how the grass root spreads, there are many such photographs. In fact, I have taken with some reference that where from it is taken. It is available in the internet. And what are the slips and how they are shifted from the nursery to the field, and there are many such examples that you can see I have taken from the net itself. And in fact, on the same slope, there are only one or several tests that have been done, especially starting with Vietnam, Thailand, China, many places that they have done this kind of test with various types of vetiver. There are various types of vetivers are there. Which one is growing over here? So before any application of the vetiver, we have to see that like we have got South Indian variety, North Indian variety, and CI map also have created 4 or 5 varieties. So each of them, before applying it, especially in the slope, we have to check that under that condition that which one is growing better. So there are some choice and experiment and validation performance that we have to check always. So under same situation with 400 millimeter rain in 10 days, that which one native vetiver, which one is eroding out. These are the tests must be verified, but most of the cases we check now these days what is the type of soil, what is the climate. So we make it prerequisite that what is the type of soil, accordingly what kind of vetiver will be suitable, that kind of matchmaking that we do now. So, in fact, the most classic example of, without vetiver and with vetiver is that this is, of course, you can say, specially recommended for most of the highway slopes, which I have shown in the beginning of my presentation, the 35 degree or 37 degree. But here you can see that it is more than 60 degree with vetiver. But there is no mechanics that we can explain that how 60 degree slope is stable over here. In fact, it is taken from this place in Vietnam. And and in fact, these are some of the case study that even taken at different slope angle that how vetiver is growing. These are taken from the resources available. and how root grows inside. There are many such, examples are there. So grass grows deeper enough to hold slope from failing. Root networks are worthy enough to check pore water pressure to zero. Root networks are such that the pore pressure, like we use, many kind of drain, sand drain used to be there 60 years back. Now PVD drain we use with geosynthetics. But we can see various such examples that here you see it is almost 70 degrees slope that where grass is growing. And here also more than 70 degrees slope. These are a classic example. But what now, as far as what we have observed and what we are seeing that things are happening across the globe, including India and in our tackling river erosion like this, you see that water flow maybe even 10 meter per second. But who are the engineers who are here? Are they engineers? No. But what changes that they have brought where no engineers' presence are there? This is in West Bengal, one of the state in the country, my home state, that what kind of work and engineering sense that these people are having? Nothing, just grass have been grown over there and it is solved. So, and common sense, like here you see no engineering, it is just only giving a guidance that, okay, plant it this manner and changing this kind of situation into this one. And also this is our Eco Task Force from Indian Army. In fact, Banna is one of the forest that created by Mr. Patanjali Jha, who is very well known in this, that he gives Vetiver slips just free of cost, especially to the Eco Task Force, and crores of these things are suppling that he has given. So many such Vetiver trainers are there across the world, and we have tremendous source and enthusiasm to bring this kind of social activity into the disaster mitigation or erosion control. And in fact, one of the example that I have taken here, it is again from West Bengal, northern part of the West Bengal. Whatever grass planted, it has grown, flood has come heavily, it has eroded, but road remained there. At least this much, 50%, 40% it has eroded. So such are the things that we look for, that how it has survived. This is my own creation over here. Here you can say in December 2020, this is almost 75 degree, 80 degree. You can see that this house is about to fail, involving the involving the people over there, 8 to 10 level that we have taken. And then grass we got from Kerala. And then those have been planted in December 2020. And then after 5 months, this is the growth of the grass. And in fact, I have visited last November and then took the full scenario of that, which is being nicely maintained by, Mr. Jairaman, Mr. and Mrs. Jairaman, and still maintained, and he has propagated it in the same house here itself. Of course, I could not take to the downstream from here where this photo was taken, but it is nicely maintained for the last, you can say, 5 years and plus. So similarly, many such situations arrive in our hilly area. We can try this one and then at least stabilize such kind of things locally, involving people. No permission is required. Involve these people only here, and it doesn't cost, because for the whatever that we have got it free. So even these days, so. This is in Sundarban. Took out, you can see Dr. Pradeep Kumar is there, myself. We took Jadavpur University students there to plant vetiver grass. On the other side of the this river, this is the saline, but we tried to choose this area. And these are all training program. We have involved one of the village teacher and contributed, gave him to take care of these things. And then all we have done over here, cleaned it and planted the vetiver within 2 days. So it is one kind of, passing the responsibility to the local club to this. This is again another in the Northeastern Hill University in Meghalaya, Professor Devesh Walia. We took the students and then planted the grass. You see the angle here. They have grown very nicely, but later on some modification took place, and finally they have uprooted all these things. And this is anywhere that whether it is accessible or not accessible, that you plant the vetiver grass and they grow, because this is a nice place to grow the vetiver grass. And you see that how enthusiasm that students have been working. And this is again in West Bengal, Vidyasagar University, where more than 120 students were involved, and even villagers that we have called them. This is all sand. It was very difficult to stand over there in July. And so we have planted this and then made the people over there in the village responsible for maintaining the grass. But unfortunately, it was not possible to maintain. And then most ideal spot for vetiver grass to grow over here like this, wherever it is. This is already done, so this part we can grow vetiver grass. This part we can grow very easily, the vetiver grass. This part is very ideal for growing the vetiver grass based on the example that I have shown right now. Even these are all, you see, 75, 80 degree slope. So these are most ideal to stabilize them, this kind of slope by vetiver grass. This is one of the applications that I visited through National Highway Authority of India to Myanmar, and took the vetiver grass here, directly planted on the slope, and then with the help of geotextile, and all have grown so nicely. Now, almost the recommendation for that almost 100-kilometer road, about 30 kilometer of the cut slope that which is to be installed. Earlier they have used someone this vetiver grass, they didn't grow. Then I went there with the vetiver grass from Calcutta, and they have grown over here in the same slope. So now the recommendation is ready. They are going to be taken out. This is as on 29 September, directly from the field. But slope engineering that we know, these are all very nice examples. See, adapted to the nature. So that is going to be sustainable, and this is in Japan. But when we do some kind of retaining wall or such kind of wall and something, they are not cost effective, they are not sustainable, because we make such kind of walls and other thing in a very shabby manner. Ultimately, they lose their standards. So what grass do? Pore water pressure, reduction, high tensile strength of vetiver roots, which we will give some of the examples of that, provides reinforcement for slopes and enhances soil shear strength. But we are not able to evaluate soil shear strength the way that it should be as it grows or it does into the field, because it will take a lot of time of research, and especially developing the constitutive equation for the bio nail reinforced soil. And whatever increases saturated hydraulic conductivity, so measuring them and modeling them and then implementing them in the field and getting the result from the field through instrumentation directly and indirectly over a long period, maybe 1 year, 2 years, I think it is still to be taken up in our discipline. So being a vegetation-based climate adaptive technology, this grass exhibits great promise in its ability to effectively address landslides problems. So let us see now erosion problem. Just I go quickly. And some of the things have been done by, geomat, which is engineered material, but something that which is missing over here, matching them with the nature has not been done. So they fail. They are not sustainable in the long run until and unless we do similar kind of things over here as it is done over there in this way. So many times we use some of the engineered material, like here you can see there is a depression over here. So so it is going to fail here later on. So these are geofoam being used. They are not only costly, but at the same time it is not matched with the ambient, nature over here. So where vetiver grass does everything all together in a sustainable manner in the same location. So such kind of slopes, this is Guwahati Shillong Road. And in this case, even vetiver grass, people come from many parts of the many parts, and they put something non-vetiver things and local some things, and then they don't grow, and then blame game starts. So we have to check these things. But before, after, there are many such again classic examples are there. And so, but there are again classic examples that where it has not grown because no watering done, because it is a living plants. And this is in our country, Border Roads Organization, Kohima, in the Nagaland area. They could not grow because there was not proper caring after at least for 1 month, you see, in the same place. And we do many kind of protection measures using the knowledge and know-how, guideline, and such kind of recommendation that available in our discipline. But it is not long lasting in many of the places. Like you see, we make this kind of things. We put this kind of things, but same thing could have been done by vetiver grass. This is a vetiver, the Vetiver Network International, TVNI. It is a wonderful website that you can get the entire world of vetiver that for the last 40 years plus how it has been growing into the erosion control and many other applications. So, and these are some of the applications, of course, even fly ash. It is not the soil. I'll go through some of the things. Fly ash, that how grass has grown. And you see that they have used coir net or jute net, and then over that, over the fly ash, and then grass has been grown, you see, from here to and here, entire. And these are again in the same way that it is being done. So how greeneries are there, you know, carbon sequestrations and other things, they are excellent. And but for this, we can go miles ahead in checking that carbon sequestration capacity is yet really excellent. There are more studies are being done, and it is to be recognized now in our discipline. This is again by Pradeep Kumar, whose example that I have taken. Jute net is also being used, and how greenery is there. This is in Delhi, nearby Delhi, in NTPC and thermal power, that where fly ash slope is stabilized, or even after 3 months or 4 months, that how they have grown on the fly ash itself. So coming to the last part of the presentation is that vetiver grass characteristics, extreme and wide range of conditions, long living perennial grass, it never dies, and temperature sub-zero, even -5, -10 degree to even more than 55 degree. pH is less than 3, acidic to as high as 10 or 10.5. Annual rainfall that it can tolerate even as high as 6 meter. And it is tolerant to high toxicity. In fact, there is a big domain about the phytoremediation by the vetiver grass in many of the waste or sewage or even industry effluent, you know, phytoremediation in the river or in the industrial area. It is a big area that coming up. And it is also called a biopesticide. They do not allow snakes or mosquito and many things. But everywhere it needs that, sustainable performance checking and its, efficacy in the long run. It is powerful. I'll show a table which is done that 75 megapascal root strength, because it becomes such a huge root, which you have seen in the before. And deep root system, which can go up to 2 meter, 3 meter, 4 meter. As I said, that highest record is about 24 feet or say 8 meter or something, 7.5 meter. And then it can withstand up to 3 to 4 or 5 months of submergence, even if it is in the flood area or even if it is in the canal area. Canal lining can be substituted using the vetiver grass. And it is non-competitive and non-invasive. This is very important. Some of the failed slope, this is a classic example taken, reference you can see here. So classic example that slope has failed already, but vetiver grass is planted on the failed slope in this way, and they are able to sustain that in the long run. So we make slope unnecessarily in this way with rigid gabion wall and other things. Then bulging occurs because of the poor drainage regulation. And so bioengineering techniques are useful approaches to prevent landslides, soil erosion, and reducing flood flow velocity with the roots deep down to several meters. And however, bioengineering technique requires more scientific research, as I have been telling, and implementation in understanding the fact of the factors that influence its effectiveness. And just buying and planting them through unskilled manpower are the biggest threat, so which we have to check thoroughly. And so qualities of a plant which you have seen over there, it should be perennial, which is mentioned there. It should exhibit xerophytic and hydrophytic characteristics if it is to survive the forces of nature. It should not compete with the cropland, like it is non-invasive, and it should be free from pests and diseases. Vetiver has got all these things which are already defined. And engineering applications are many. Rainwater harvesting, protect infrastructure, protect coastline, even like protecting the failed slope, or rejuvenating, or refurbishing the failed things. Protect flood-prone land, protect farmland, and finally, just few examples I want to give. How fast whatever grow. You see, entire of this thing, imagine from the geotechnical perspective that stabilizing a slope, and here you see twin tunnels are there, and over that this approach and other thing, it is entirely done by no pitching of the wall, no retaining wall, nothing, simply by the grass. Simply by the grass. And see, it is vetiver grass, how it has been planted over there. So we can think of, combination, not that I'm saying that 100% recommended, but we should think of grass is just not for greenery. We have to think it that how it can be brought into the main role that it can play in stabilizing the slope and erosion, controlling the erosion. And these are some of the things that in Guwahati, after 3 months, how whatever grass has grown over there. It is almost 70 degree, 80 degree, you see, earlier before this. And these are again slope and mining area restoration. So we are getting heavily into the mining area restoration using the vetiver grass, and another part is hydroseeding, which is again a different topic, which we can take it up later. So finally, I'm showing that how much grass can grow, how thick that it can grow. And then Paul Trung is here. You see that he is the most well-known person in the vetiver world, especially from the geotechnical point of view. But we have many other experts. And vetiver grass is having a deep, extensive root system. And compared to several other grass, you see that what is the range of tensile strength. Because when you make the tensile strength of this in that way, and there are many such literature available. This is resource from Dithal in 2013, that what are the, suggested method of bioengineering. There are a lot of huge literature available. So I have taken just bits of that, and that how and what are the method of bioengineering, what kind of effect that can be obtained. And then, how we can make use of that. We have to be very much particular about that. Besides that, erosion and vetiver control, erosion and the slope stability, which is the topic today, it is used heavily in the traditional medicine. It is an essential oil costing from minimum 20,000 rupee per liter to 60,000-70,000 rupee per liter. And and roots as a flavoring agent. Many of the restaurants now they are using the vetiver roots into the bottle full of water. Root mats for door, window, screen, and during summer for cooling effect. In fact, in North India, when we say khas or whatever, they don't understand because it is from Tamil name. When we say khas, they say that, oh yes, it is being used with the cooler. But these days, most of these things are replaced by some synthetic material or some other alternatives, wood-based material. desert cooler in North India, eco-friendly soil binders, and routes for preparing sharbat, like I say, soft drink during summer, especially in North India, socioeconomic life in the rural population. I can make the list of hundreds there, that varieties of uses that of this vetiver gas. Probably this is the only species probably the nature has given to us that which economic footprint is really, really far, far, far excelling any other, say, natural, say, system, natural things that are available in our earth. Then, conclusion part, I would say public acceptance of vetiver as a form of wastewater treatment. We are using it in many of the vetiver floats. Many are using this to clean the wastewater where very high standards for water quality are expected. Some applications are there. The enormous cost benefits associated with it mark the beginning of convincing both authorities and the public that phytoremediation, particularly the vetiver grass, is a viable wastewater treatment system. And vetiver's ability to uptake nutrients, minimizing sinusoidal effects of climate with season, and investigating another possible advantage of functional vetiver as disinfectants is getting more popular. There are now enough evidences that vetiver system is a very effective, economical, community-based, and environmentally friendly, sustainable bioengineering tool that protects infrastructure. I have given some example. And however, it must be stressed that the most important keys to success are good quality planting material, which I have highlighted also in the previously, and proper design and correct planting techniques. Apart from erosion control, whatever system can help in poverty alleviation, because 1 square meter area, one plant in 1 to 2 years of time gives 50 kg, minimum 1% yield, can extract 500 ml, 1 meter square, you can say at the most. So 500 ml is equivalent to Indian rupee 20,000 or even 10,000, say. In the retail market is very high, 2-3 times more. So in 1 meter square area, if we can get 10,000 rupee yield, Indian rupee yield, I think where you get this much of yield from the ground, that which we can think of. And we do not know many aspects of the bio world, but together we can make life sustainable. And I think you will agree to say that the vetiver is not one of the champion. This is, in fact, I have grown in my house only. These are the other ingredients that you can see, but I don't have to explain that, which are now available in the market. And in fact, you can see now this was Ramnath, that he is very well known with the vetiver. Many such products. This I have planted in our second campus of an IDM, but it has grown within few months of time in Andhra Pradesh. So finally, I would say that thank you very much for your patient listening to what I tried to convey through this presentation. So many of you, if you want to see my Twitter or my Facebook, you will see many such posts. In fact, all my slides with minimal, explanation, they are available in a series. More than 2,000 such slides are available in my Facebook. You can check that. Thank you.